Let's talk about points, lines, and planes. You have a foldable, and there's a front side and a back side. The front side has just a grid, and the back side has the word backside. If you lay the back side flat on your desk and you fold to the middle, you will have something that looks like this. So we'll talk about the terms point, line, and plane, and what it means to be collinear, coplanar, and intersection, and then do some problems with these. So let's start by talking about a point. A point is pictured as a dot. So we put a dot on our paper, we name it with a capital letter. For example, this is point A. There is no symbol for point, and it has neither size nor shape. So when we're writing down the things that we need to see or need to remember, we say, okay, it was drawn as a dot. We name it with a capital letter. And there are no symbols. So we call it point A, for example, capital letter. And the facts are that it has no size nor shape. Okay, so then we need to talk about what it means to be a line. So a line is made up of an infinite number of points. It has no thickness or width, and there's exactly one line through any 2 points. So if we have 2 points, we can make a line. We name it by listing the points, the 2 points that are on the line, in this case P and Q, or we could name it by a lowercase script letter. So there's a difference between uppercase or capital letters for points, and a lowercase script letter can also be used to name a line. So when we want to name that line and we call it line M, we have to use the word line with M behind it. We can also call it line PQ, or we have a symbol for a line, and that line is a line with an arrow on each side, line PQ, or we can also switch the order and call it line QP. So when we're writing this down, how do we draw it? It's a segment or line with 2 arrows, with arrows going in both ways. Okay, and how do we name it? Well, there's lots of ways to name it. We can use the word line and then the script case M, or we can say line PQ, always capital letters for points, or line QP. Order doesn't matter. So as far as a symbol is concerned, our symbol looks like a double arrow-headed line, and then the letters, capital letters P and Q below it, or line QP. And there is no thickness. And we have to use 2 points to name a line, always 2 if we're naming it by points. So if we had a big old line with 17 points on it, we don't have to name it by its 17-point name. This isn't line A, B, C, D, E, F, G. It's line FG or line BC or line EF, only 2 points to name a line. Okay, so next we need to talk about what it means to be a plane. So a flat surface that goes off in all directions, infinitely in each direction, is called a plane. But we put a bounded region around it so that we can tell that there's actually a plane pictured here. We know that it keeps going forever and ever and ever, but we bound it with a parallelogram or a rectangle or a square around the outside. And there is exactly one plane through any 3 points that are not all on the same line. So because B, C, and D are not all on the same line, we can create a unique plane. If B, C, and D were on the same line, then there's lots of planes that can go through it, an infinite number. But B, C, D is a unique plane. And we name it with a capital script letter if we are naming it by its plane name. Notice there's no dot here, no point. That's not point K, it's plane K. Or we name it by the 3 points that are not on the same line. So because there are 3 different letters, we can name it in 6 different ways: BCD, CBD, DCB, etc. Oftentimes we often just go by alphabetical, but you have options. So a plane is drawn as a box, parallelogram, rectangle, square. It is named either by its script, capital letter, when there's no point next to it, or by 3 points that are not all in the same line. And so in this case, it was plane K or plane BCD. So plane K, plane BCD, again, those capital letters. There's no symbol for a plane. And as far as facts goes, it has no thickness, but it has 2 dimensions. Like a line, there's no thickness. All right. So now that we've talked about planes, let's talk about what it means to be collinear and coplanar. So space is your 3-dimensional set of all points. And if things are collinear, do you see the word line in here? They all have to lie on the same line. And coplanar, so there's part of plane here. Coplanar means that they lie on the same plane. So if I have 3 points that lie on the same line, they're called collinear. A, B, and C are collinear. But B, D, and C are non-collinear, meaning they are not all together on the same line. We can get a line through B and C, and one through D and C, and one through B and D, but they aren't all 3 collinear. Coplanar means they all lie on the same plane. So P, Q, and R are all coplanar. They lie on plane S. If I want to show a non-coplanar point like T, I would put it outside of the box. And that means that T is either above the plane or below the plane, or to the right or to the left of the plane. So collinear, there is, has multiple points all on the same line. There is no way to name it. It has no symbol. And any 2 points are collinear. You can always make a line through any 2 points. Co means together on the same, and we see the word line, so together on the same line. In order to show coplanar, we have multiple points or lines all in the same plane, in the same box. And again, no symbol, and it takes 3 non-collinear points to make a plane. In other words, they've got to form a triangle in order to be part of a plane. All right, so our last term for this piece is called intersection. And the intersection of 2 or more geometric figures are the points that they have in common. So 2 lines might intersect in a point. If I have line AB, for example, here's A, here's B, and I have line FE as well. AB and FE are intersecting. We get lazy and don't put the dot there, but notice that G has been listed here. G is the intersection point of those 2 lines. Likewise, I can have a line and a plane intersecting, for example. Line M, this is a cursive, curly, lowercase line. That line M is on plane P, but line N is not on plane P because it's going above plane P, intersecting it at F, and then we use dashed lines to show that it's going behind, so it's invisible until it gets outside of that plane. So line N is not coplanar with plane P, but point F is coplanar with plane P. And then we can also have two planes that don't intersect because they're parallel, but we can have two planes that do intersect. And when they do intersect, it's like having pages of a book. The binding or the cover of the book and the pages of the book are going to intersect at the spine of the book. That spine of the book is a line. So plane P, notice no dot, plane P and plane Q are intersecting at line M, the spine of the book. So anytime we draw an intersection, we're drawing figures that are crossing. There's no name for it, there's no symbol for it. Two lines can intersect at a point unless they're parallel, and two planes can intersect at a line unless they're parallel. So lines intersect at points, planes intersect in a line. All right, so then we're going to find our other notes sheet. The other notes sheet has points, lines, and planes with some examples on it. We're going to talk about those. So example 1 says, hey, I need to know if you can tell me which line contains point Q. So we go identify point Q, and we say, ooh, there's a line that contains it. It intersects that line. What line is that? Well, a couple ways we can name it. We could name it by its lowercase script, and that means that we're going to call it line C. We can't use the symbols. Or we can say that it is line TR. Or we can call it line RT with a symbol of a line on top, and RT, we can change the order. We could also call it line TQ or QT. Lots of different names for it. Second example says, hey, tell me what plane contains points S and T. So I see point S right here, I see point T right here, and in order to name a plane, I can't just call it plane TS because there's lots of planes that would contain a line that goes through there. Lots of pages in a book that have a spine, or lots of pages that meet in a spine. So we need to name that plane, and anytime we name a plane, we can either find the capital letter that does not have a point next to it. That's the name of the plane, and there's no symbols, so we can call it plane A. Or we can call it plane STR, all capital letters, or plane SRQ, QRS. As long as the three letters, the 3 points form a triangle, then we're fine. The one thing that we cannot say is we cannot talk about point V because point V is not on the same plane as T and S, not pictured on the same plane. There is a unique plane that would go through T, S, and V, but it's not currently pictured. All right, example 2 says, let's talk about what things are on the student desk. So anytime you see a rectangular or a parallelogram shaped figure, we know that that's a plane. So we have this composition book that is plane, and we use a 3-letter name for a plane, so JKL. N could be part of that, but just because there are 4 letters, 4 points, doesn't mean that we're going to name it by 4. Then we have this figure, this pen, and it's a line, so symbol, line, symbol on top. We could call it PR, we could call it PQ, we could call it QR, but when we name a line, we're naming it with 2 points, not 3. Always 2 points, not 3. And then finally, we have one more thing that's labeled. The coin is point, and there's no symbol for a point, so point M. And then we have a music device that we don't need to include because there are no points listed. All right, example 3 says, let's draw a geometric figure. So we're going to draw a figure and represent its relationship. So we want a line QR. That means that we're going to have a segment connecting Q and R with arrows going both ways. And a line ST intersecting at point U. And Q is at the point -3, -2. So -3, -2 means I'm going 3 to the left and 2 down because they're both negative. We always do X first and Y second. So -3, -2 is the point Q, capital letter for a Q. And R is 4, 1, so 4 to the right, 1 up, capital letter for R. All points are named with capital letters. And we connect them, put the arrows on there. And then S is at the point 2, 3. So if we go to 2, 3, 2 to the right, 3 up is S. T is -1, -5. 1 to the left, 5 down. Label it with a T. Connect the dots. And if we do a nice job, maybe use a ruler, we're probably going to get a point U that's about here. We could check. It looks like we're going down 3 and over 1, down 3 over 1, maybe not, but that's going to be our U. Not perfect. Don't have a ruler. Point V is coplanar with these points, but it's not collinear with QR or ST. So V can't be on QR, it can't be on ST because that would make it collinear, but V is on the plane, so we can put V anywhere we want to as long as it's on this coordinate plane. So we pick a place that we like, maybe this point right here, -2, 2 is going to be point V. Put a dot there for the point, capital letter to label it. All right. So then we have to be able to interpret drawings. So being able to look at things and decide what we see. So we have this pyramid shaped thing on top of a plane and a line, and they ask us how many planes appear in this figure. Well, this rectangular one is a 1, but then I see a base that is a pentagon, has 5 sides. So this side goes up to point A, right? So there's 1, there'll be 2, 3, 4, 5 planes plus the one on the bottom. I see 6 planes pictured. We want to name 4 points that are collinear. So 4 points that are together on the same line means I have to find 4 points all together on the same line. Ooh, H, I, C, and F are all on the same line. So H is capital letter, I is a capital letter, C is a capital letter, F is a capital letter. Let's put a comma between them because we made a list and we finished that question. The intersection of plane GCA and plane P. Plane GCA, ooh, that's this back plane that I had shaded earlier. And plane P is this plane down here. Where does this triangular shaped plane intersect our rectangular shaped plane? Right there, line CG. So put our symbol on top, or if we don't remember the symbol, we could just write line CG, line GC. All right, at what point do line JI and line DC connect? Line JI is this one, line DC is this one. So it looks like CD's on the plane and JI is going through the plane, and it doesn't appear to intersect at all. So they don't. And it says to explain, well, CD is in plane P, and I is a line separate from that is on line JI. And I is not intersecting CD, so it can't be intersecting the line JI can't intersect CD. All right, and then finally we have an example of model intersections. So they've shown us a biplane. It has 2 main wings that are stacked above each other. So here's one wing and here's two. The struts connect the wings. So up and down, those are the struts. And then the fly wires are going diagonally from the main body of the wing to the stacked pieces. So these are our flying wires. And it says, let's talk about what's modeling these things. So each wing models a plane, because it has a length and a width, but it does actually have a thickness, but as a model, it's a plane. The intersection of the strut and the wing, where the strut and the wing intersect, so where this plane intersects this line, looks like it's going to be a point. And the crossing of two fly wires is going to be two wires are going to also cross at a point. A strut and a wing, depending on the thickness of the strut, I guess. The strut and the wing could be a line. It looks like our strut is kind of a plane, and the wing is also a plane. So I'm going to modify that and think that maybe that is a line. It's hard to see, it's not in 3D, but it looks like there's some thickness there, not a wire. All right, see if you can do the exit ticket.